They're in your everyday life, to the most isolated places on Earth. They're microplastics, and they're everywhere.
If you come up to this and you have your lens, you'll see like a little dot of light. Microplastics, as their name implies, are very small pieces of plastic. So the definition per the state of California defines microplastics as pieces of plastic that are less than 5 millimeters but greater than 1 nanometer in any of their 3 dimensions. So for reference, you can think of the eraser on a number 2 pencil. That's about 5 millimeters in diameter.
They could be intentionally made that size, or they can end up being that size. So that's what we know as a primary microplastic and a secondary microplastic. So primary microplastics are intentionally made to be within those size dimensions. Some great examples of that are microbeads that are used in detergents. Great example is glitter. And a secondary microplastic are actually microplastics that break off of larger pieces of plastic. So they could break off of our piece of clothing as a fiber. They could break off of water bottles, for example. So that is what we know as microplastics. They've been found in glaciers, they've been found in stormwater, they've been found in our drinking water, they've been found everywhere.
And the big question is, what do these microplastics mean? Not only to the environment, but to human health as well.
There is some evidence to suggest that microplastic pollution in surface waters, soils, and sediments may impact the microbial diversity and function in those matrices. So that could relate to nutrient cycling. So think of like the carbon cycle or the nitrogen cycle. And so this can impact negatively the delivery of really essential ecosystem services. So broadly, that could be how well our crops grow in an agricultural area, or how much carbon becomes locked into our soils and sediments, which directly would relate to climate change.
Potential impacts on agriculture and climate change are not the only concern scientists have when it comes to microplastic pollution. They're also studying how animal populations may be impacted.
There's an interesting anecdote on how they may potentially be affecting wildlife, specifically Coho salmon. So a research project was done in the Pacific Northwest, whereby they noticed that Coho salmon population was declining rapidly. So came this question like, what is it leading to their population decline? And they found out, because where they would spawn would be right next to urban roadways, that small pieces of tires would wash away into these streams or like these waterways. It turns out that the very thing that makes plastics not break down very easily in the environment, an antioxidant known as 6-PPD, that when it is out in the environment, it reacts with ozone, and you have this transformed byproduct known as 6-PPD quinone. That turns out to be the very thing that led to the decline of the Coho salmon population in the Pacific Northwest.
If the microplastic pollution near the salmon spawning area is what led to their rapid decline, then what does that mean for us? As mentioned earlier, microplastics have been found in nearly everything.
In terms of health impacts of microplastics, especially human health, there's a lot of emerging research that's coming out about that, specifically about the presence of microplastics within our systems, because they've been found in things we consume such as salt, beer, drinking water. Do they potentially leach out different contaminants that may actually harm our human health?
Because of the environmental and health concerns, the City of Santa Barbara's Creeks Division wanted to know the specific levels of microplastic pollution on a local level.
Based on presentations and literature and media reports that we were seeing, we became concerned that microplastics might be an issue in creeks in Santa Barbara, and then the microplastics that would be discharged to the ocean. And so I reached out to several contacts at UCSB and got in touch with Dr. Patricia Holden, who we've already worked with extensively on other issues. And she was already studying microplastics and had a couple of graduate students who were already working on it. And so we put together a proposal that we submitted to the UCSB's Associated Students Coastal Fund, and they generously supported the project. The proposal that we submitted was to understand how large of an issue microplastics are in Santa Barbara, and specifically in creeks, and what are the concentrations during the different storm events, and also could we possibly reduce some of the microplastics getting to the creeks by some of our stormwater activities, especially street sweeping.
With the proposal submitted and approved, Becca and Tim Neat began their research.
So we like to begin our research with the story of how these pollutants may end up in our environment and the impact they can have. We had an awareness that these microplastics were somehow entering our oceans and ending up in our sediments there. And other literature in this field has shown that microplastics are conveyed through stormwater runoff, especially in an area with a lot of impervious surfaces, so concrete and asphalt. So we hypothesized that stormwater runoff could be a contributor of microplastics into our coastal oceans. And Jill considered the different management practices for pollution mitigation that the city already has in place. And street sweeping was a management practice of interest to understand if it was effective at reducing the concentration of microplastics entering our oceans. So we developed a research question which probed at that, how many microplastics were entering our oceans during stormwater runoff events, and how effective is street sweeping at reducing the number of microparticles that enter our oceans through stormwater runoff.
We've collected stormwater samples, and the city is collecting the samples, and unlike most of the times when we sample, we can't just collect a bottle. There's actually a pretty low concentration in the environment, and because of the methods that UCSB uses to quantify the amount of microplastics, we have to filter up to 100 gallons of sample of creek water every time we give them a sample.
And Tim Neat and I used our methodological approaches in the lab to extract and isolate and chemically identify those microparticles. So that's through filtration, and then we use a fancy tool called a Fourier transform infrared spectrometer, which based on infrared light wavelengths can give us an idea of the chemical identity of the microparticle in question, so that we confirm yes or no whether or not it's actually a plastic or simply a microparticle.
The research did in fact show meaningful concentrations of microplastics in our local creeks after a storm event. What remains is understanding if street sweeping could be a good strategy in reducing micropollution in Santa Barbara.
We've collected samples from the street sweepers. We take a portion of that and also send that to UCSB, and we haven't learned the results of that yet. So if UCSB does find that there's a substantial amount of microplastic in the street sweeper debris, that gives us some good information that street sweeping could be an excellent method to tackle some of this pollution.
We're learning more and more about microplastics and microplastic pollution every day. Taking steps as a city to learn how to reduce micropollution here at home. But there are steps we all can take to reduce our own micropollution footprints.
When we have conversations about plastic pollution, there are a number of different ways that this issue can be addressed. And so I just encourage folks to consider what they are able to do based on their circumstances. Sometimes plastics are very necessary materials, which is why we've seen them become such a popular material in our industries and for consumers. So Tim Neat and I are really focused on inclusive solutions to environmental problems and engaging and empowering individuals to take action to the extent that they're able to help.
Say no to a plastic bag when you're at a grocery store. Choose to reuse a plastic container, for example, that you may have purchased a couple of times before you throw it away. Recycle as best as you can as well. Follow those awesome recycling guidelines that are out there. Consider reduction a lot if you have the means to reduce your plastic consumption, as well as reuse. Another way that I think that you can certainly limit or rather contribute to the efforts on limiting plastic pollution, specifically microplastic pollution, is by talking to your legislators.
Every little bit helps, and it's really just up to your background and your level of ability to participate, and it's nothing to fear, but something to be aware of and something that we can all make a difference in reducing.